So what we're going to look at is some kind of unusual types of stoichiometry problems. In this one, we're going to look at limiting reactants and sequential. So limiting reactants is a very common phenomena. A lot of times we just don't really realize it, but we basically it's whatever thing stops the reaction. So once chemical reactions start happening, they're going to keep going until we run out. So a kind of simple example is like if you have a car, you know, your parents have a car. The car is going to keep driving until like we run out of something. So typically the thing you would run out of is gas. Or sometimes something can clog up the engine and maybe you're not getting enough oxygen. So that could be the limiting reactant. But basically anytime you have a reaction, something's going to limit it, something's going to stop it, or the reaction would just keep going. So a couple things to kind of watch out for. When you do a limiting reactant, it's not necessarily the thing you have in the smaller amount. So just because you have 2 grams of hydrogen and you have 10 grams of water doesn't mean that the limiting reactant is the hydrogen. You actually have to do the problem because it has to do with moles, not just amount, grams. Whenever they give you the amount of 2 or more reactants, you need to assume that it's a limiting reactant problem. So they're not always going to come out and tell you it, but you need to be aware of it. So a couple of things here. You make sure you write your balanced chemical equation. Make sure you use your mole ratios. And then obviously you want to calculate the amount of it that you're doing. So what we're going to do is do 2 examples and then go from there, if it likes me. Okay, so there's 2 different ways that you can do limiting reactants, and we'll show you both. You just have to decide which one you're doing. So the first one is this one. We want to know what mass of carbon dioxide could we make if we burned 16 grams of methane and 48 grams of oxygen. So first thing you have to do is write your chemical reaction. So it's a combustion. So we have methane plus oxygen. It gives us CO2 and H2O. We balance it appropriately. So the first way that I'm doing it here is you can see I turned them into moles. So I took my methane, turned it into moles, saw how much moles of methane I have, and then I can say, oh, I have 48 grams of oxygen, turn that into moles, and I said I have 1.5 moles of O2. So what you can do once you have it here is this is more of a logic game, and if you don't like logic, you're not going to do it this way. You look at the reaction here, and you can see up here, for every 1 mole of methane I have, I need 2 moles of oxygen. And if you look down here, I don't have that. I have 1 mole of methane, but I only have 1.5 moles of oxygen. What that means is I'm going to run out of oxygen. Like that's the thing that's going to limit me. So that would be my limiting reactant. And if you do it this way, what it does is it saves you a little bit of time because you only have to do 1 stoichiometry problem. So we have our 1.5 moles of O2, and we do our mole ratio. And what you do is then you only do it for the one with the limiting reactant. So I take my moles, I do my mole ratio to the CO2, and then I say, okay, times its molar mass. So I could make 33 grams of CO2. So it eliminates the need to do 2 stoichiometry problems. But you have to have a little bit of kind of logic in it. If you don't like this way, you can also do it this way, where you just do 2 stoichiometry problems. So I take my 16 grams of methane, and I do a grams to gram problem with the CO2. And I take my 48 grams of oxygen, and I do the same thing, and I go to my grams of CO2. When you do it this way, you're doing a little more work because you're doing 2 stoichiometry problems, but then you come down to, you have 2 answers. One of them is correct, one of them is completely useless. When we're talking about limiting reactants, we're talking about the lower number. So when you look at your answers, you have 44 grams, and you have 33 grams, well, you don't want the one that's higher because that would mean that you have more, you have the ability to keep going, and we don't. So the lower number is your answer, which is 33 grams, and you'll notice it's exactly the same answer as we got the other way. So again, just depends on what you like. And then when you know which answer you're choosing, the one that gave you that, the reactant that gave you that, that's your limiting reactant. So you have that ability to do that for that one. Another thing you can do, and they frequently ask you to do with limiting reactants, is they say how much of the excess reactant is left over. So what you have to remember is we said that, if it likes me, we said that the oxygen is our limiting reactant. Well, that means that the methane is our excess reactant. So you have to be aware of that. So when we're talking about that, that's what we're talking about. So how much of the excess reactant is left over? So methane is our excess reactant. So what we're doing is we do another stoichiometry problem, and we take it from our limiting reactant, which is our oxygen, and we go to methane. So again, here I just start with my 48 grams of oxygen. I divide by my molar mass. I do my mole ratio, excuse me, and I multiply by my molar mass of my methane, and you get an answer. And this is how much of the chemical would have been used in the reaction. So 12 grams was used up. And if you look back at the original question, it says that we started with 16 grams. We used 12. So the answer to the question of how much of the excess reactant is left over is there's 4 grams left, because that's what we didn't use. So there's 4 grams of methane that would still be around for it. This one. And here's just another one of the limiting reactants. I would suggest that you do it whichever way you like. Again, either try the logic-based way or try the one where you do the actual stoichiometry. But again, you have to have your answer. I'm sorry, you have to have the right reaction. So if you look here, we have the nickel 2 chloride, and we have 25.9 grams of it. We have sodium hydroxide, and we have 10 grams of it. It's a double replacement reaction, you can see, and make sure it's balanced and that your charges are balanced. Whichever way you do it, you'll get the same answer, but you can see here what we did was I just did it the longer way with the stoich, and you get 2 answers, either 18.5 grams or the 11.61. The larger one is not what you want. You cross it off. The answer is the 11.6 grams. So what that means is we can make 11.6 grams of the nickel hydroxide, and that's it. Then the reaction would stop. It also means that sodium hydroxide is our limiting reactant, and it also means that the nickel chloride is our excess reaction for this one. And then the only other thing on this one that you could do is they could have you do that excess again. And again, when you do the excess reactant, it's always exactly the same. You go from your limiting reactant to the excess. So again, sodium hydroxide was determined to be the limiting reactant. So we do a stoichiometric problem from that to the nickel chloride. So you can see I did that, sodium hydroxide to moles, mole ratio, times the new molar mass. That tells you how much of the chemical was used up in the reaction, and then you just subtract from your starting amount. So the beginning of the reaction, we had 25.9 grams. We used 16.2 grams, which means that there is 9.7 grams left for this one. So this is limiting reactants. You definitely need to practice these. These are a little different. There's a little more logic to them that you have to do than just normal stoich. And then when the next one's up is we have sequential, and we have solutions, and then that's it for stoichiometry. So a lot of this is just logic, and a lot of it is just following the pattern of how do we convert in and how do we convert out. So hopefully this video helped.